Right, this is Geometry A, Unit 3, Lesson 3, Reasoning and Proof. We're going to do some reasoning in algebra and geometry. And we're going to do a couple of proofs. I'm not going to go into detail explaining what a proof is, but I'm just going to demonstrate a couple of proofs. All right, so here's one proof that I want to demonstrate, and I'm going to explain some of the important parts about proof. Given. Most proofs have a given. All proofs have a given. Something that we start with. Given x squared plus 5. Or not, let's not do that. Let's do x plus 5 equals 9. Prove x equals 4. So given x plus 5 equals 9, prove x equals 4. Okay? And there are lots of ways to write proofs. We can write two-column proofs, we can write paragraph proofs, we can write flowchart proofs. You're going to learn about all of these things. We typically start with a two-column proof, mainly so that we understand that every statement must be justified with a rule or a reason that justifies it. So the left-hand column is going to be for statements. The right-hand column is going to be for rules or reasons. Okay, so what allows the thing that we're saying? Every statement must be justified with a rule that says it's true. Okay, so here's statement number 1, and we typically, so the other thing that proofs have, they typically, or not typically, they always start with the given, or should always start with the given. Okay, so the very first statement is what's given. X plus 5 equals 9. How do we know x plus 5 equals 9? What rule says that? It was given. Okay, it was given. Then every proof must end, and this is absolutely true, every proof must end with the statement we are trying to prove. X equals 4. Okay, x equals 4. All right, so, and actually I'm going to complicate this thing just a little bit. I'm going to change something. Instead of x plus 5 equals 9, I'm going to say 9 equals x plus 5. Because I want to put in one more step here to clarify something. X plus 9 equals 5. X plus 5 equals 9. Sorry, x plus 5 equals 9. There we go. All right. And that's just the same thing I wrote. I want to switch the order around. 9 equals x plus 5. There we go. Okay, so 9 equals x plus 5 is given. 9 equals x plus 5. Okay, we're going to end with what we're trying to prove, which is x equals 4. Okay, so if you don't know how to do a proof, you can always state the given as your first statement. And you can always state what you're trying to prove as your last statement. What is missing, however, is the reason or the rule that justifies the last statement, because prove is never a reason or a rule in a proof. Okay? All right, so here we go. Let's take it step by step. You're familiar with how to solve an equation. You think, or probably think, hey, I know I want to get the x alone, so I want to get rid of the plus 5. I get rid of by doing opposites. The opposite of plus 5 is minus 5, so I'm going to subtract 5 from both sides. And we end up with x equals 4. Okay? But the question is, what rule justifies that? What rule says I can subtract 5 from both sides? We have to cite a rule. That's what's different between just doing a problem and operating a proof. A proof has to be justified. The rule that allows us to subtract the same thing from both sides is called the subtraction property of equality. Subtraction property of equality. It says I can add or subtract the same thing to both sides. Subtraction property of equality. Okay? And now we're ready for our last step. Now notice 4 equals x is not exactly the same as x equals 4. Okay? So in order to do a proof, we've got to be thorough. We've got to put in that as our final step. X equals 4. And notice what happened here is we switched the order. If 4 equals x, then x equals 4. What rule says that we can do that? There is a rule that says we can switch the order of equality. And that is known as the symmetric property of equality. Symmetric property of equality. Okay, some people try to say it's the reflexive property. The reflexive property says anything equals itself. So like 5 equals 5. That's the reflexive property. X equals x. That's the reflexive property. The symmetric property says I can take the order, like 4 equals x, and switch it around to x equals 4. Symmetric property. Think symmetry, left and right symmetry. Okay, so that's a proof, all right? And we could write it as a paragraph proof. We could do a bunch of things with it, but that's a proof. That's a 2-column proof. It flows logically from step 1, from the given, to step 2, to step 3. In this case, it's a very short proof. There are longer proofs. Some of the more interesting proofs are many pages long. Okay, but that's a proof. All right, let's do one more proof, or actually, I think I'm going to leave it at this, and I'm going to do another proof, a proof of the vertical angle theorem as a separate recording.